In this video, we are going to explain about a project titled Learning Deep Gradient Descent Optimization for Image Deconvolution. So now coming to the introduction part, Learning Deep Gradient Descent Optimization for Image Deconvolution is a groundbreaking technique that leverages the power of deep learning to tackle the challenging problem of image restoration. By formulating image deconvolution as an optimization task and employing deep neural networks for learning, this approach surpasses the limitations of traditional methods and achieves the state-of-the-art of results in image restoration tasks. Its adaptability to diverse degradation scenarios and reduced need for manual tuning make it a promising direction for advancing image processing techniques and enhancing the quality of images in various real-world applications. The advantage of employing deep gradient descent optimization is its ability to generalize well to various types of image degradations, even those not encountered during training. So now coming to the objective part for this project is to advance the field of image processing by creating a learning-based framework that combines deep neural networks with gradient descent optimization to achieve state-of-the-art image restoration results. By training on extensive data sets and formulating image deconvolution as an optimization task, this approach aims to overcome the limitations of traditional methods and provide an efficient, adaptive, and user-friendly solution for image restoration tasks, enhancing the quality of images in a wide range of practical applications. This learning-based approach brings the advantage of generalization, allowing the model to adapt to different types of degradation not seen during training. As a result, the objective is to achieve superior performance in restoring images even in challenging and unseen scenarios. So now coming to the requirements part, we have two types of requirements, that are hardware requirement and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first upload Pascal VOC dataset. In this step, the Pascal Visual Object Classes, that is VOC dataset, is collected and uploaded to the system. The Pascal VOC dataset, that is Visual Object Classes dataset, is a widely used benchmark dataset for object detection, segmentation, and classification tasks in computer vision. Second, generate and load RGDN model. In this phase, a model called RGDN, that is stands for Residual Guided Dense Network, is generated and loaded into the system. This model is a deep learning architecture specially designed for image deep learning tasks. It leverages dense connections and residual connections to effectively learn and restore clear images from blurry inputs. The model is pre-trained on large datasets, enabling it to generalize well to various deep learning scenarios. Third, upload blur image and get deep blur output. In this interactive step, users can upload a blurry image of their choice into the system. Once the image is uploaded, the RGDN model processes the input using its learned parameters and deep learning capabilities. The deep learning processes aims to remove the blur and restore the original details of the image, providing a clear and sharp output. Fourth, exit. After obtaining the deep blur output for completing the desired image deep learning task, the user can choose to exit the system or end the deep learning process. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as PyCatch. In this we are containing a Python file which is containing the Python script in it. Another folder named as model. In this we are containing some datasets over here in the files. Another folder named as text images. In this we are containing some images for testing it. And the folder VOC dataset, in this we are containing two folders, that is blood images and deep blood images, and in these two folders we are containing some blood and deep blood images over here. And here data reader and RGDN are the two Python files which are containing the Python scripts in it, and here this is the main Python file. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here we have a graphical user interface. With this we are interacting with the program. Now click on upload Pascal VOC dataset button to upload the dataset for getting the output. So here I am selecting VOC dataset folder over here, and now select folder. Now click on select folder over here to get the output. So here in this white color text you can see dataset loaded, and now click on generate and load RGDN model button to generate and load RGDN model for getting the output. So here on this screen you can see that model is loaded, and now click on upload blur image and get deblur output button to upload blur image and get the output. So here I am selecting, suppose here I am selecting this image, and so now click on open button over here. So here on this screen you can see that first image is the original image and second image is deblur image obtained over here from RGDN model. And in text area, by closing this image, in this text area you can see that TSNR value as 88 over here and SSIM as 84% over here. Both values closer to 1 will be considered as best quality image, and closer to 0 considered as worst quality image. So you can similarly try with other images, and so by clicking on exit button you can exit with this application. So now coming back to the conclusion part, overall this technique's objective is to enhance image quality and restore valuable information from degraded images, benefiting various fields such as medical imaging, surveillance and photography. Its potential impact is evident in improving the interpretability and reliability of images in critical applications where clarity and accuracy are paramount. As deep learning and optimization methodologies continue to advance, learning deep gradient descent optimization for image deconvolution holds great promise for pushing the boundaries of image restoration and furthering the development of cutting-edge image processing techniques.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.